Okay, yes, on this video we are going to see two examples on how to use the formula that we previously obtained, but in the Laplace inverse. Okay, so you have this example, and then we are going to use this example. Okay, so when are you going to use this formula? When you have an exponential on the s domain, all right? As you can see here. Okay, I'm going to do this. I'm going to write it just in the form of the formula. Exponential minus 2s, 1 over s minus 4. And check this out. Down below, I'm going to write the formula. The formula of the Laplace inverse, over here the inverse, is exponential minus as f of s. And this is equal to f of t minus a, u of t minus a. Now, the first thing to identify is what is the value of a. Clearly here, the value of a is equal to 2. Alright? Now, what is the f of s? Okay, the f of s is this part. F of s is equal to 1 over s minus 4. Okay? So, to do the Laplace inverse, so you obtain this and this, the value of a, and then you need f of t minus a. Okay, now what you have here is capital F of s. If you apply the Laplace inverse of this, what you get is f of t. The Laplace inverse of this is f of t, meaning the Laplace inverse of 1 over s minus 4. Now this is very easy. It is exponential of 14, right? But this is f of t. For the formula, what you really need is f of t minus a. In this case, the value of a is equal to 2. So f of t minus 2 is equal to the exponential of 4t minus 2. Okay, so the Laplace inverse of this applying the formula is f of t minus a is this part, exponential of 4t minus 2, and then times u of t minus a, u of t minus 2, and that's it. This is the Laplace inverse of this. Okay, again, it's very confusing because you have to first identify what is the value of a, what is f of s. From the f of s you get f of t, but you don't need f of t. What you need is f of t minus a. So all you have to do is to evaluate this in t minus 2. So you just replace the t by t minus 2, exponential of 4t minus 2, and then you plug in this formula, and then you get the Laplace inverse. Okay, so this is very simple, but you have to practice a lot. Okay, now let's use the other formula, the other example. Okay, for the other example, I'm going to write like this: the Laplace inverse. I'm going to write first the exponential minus 1/2 of s, or minus s over 2, and then s over s squared plus 9. And again, you have to identify what is the value of a and what is the value of f of s. So the Laplace inverse of, again, writing the formula, exponential of minus as f of s, and this is equal to f of t minus a, u of t minus a. Okay, so here what you have to identify first is that the value of a in this case is 1/2. Now the minus is the same, so the value of a is actually 1/2. Okay, now very clearly here f of s is equal to s over s squared plus 9. Okay, now to find the Laplace inverse, what you need is f of t minus a. From here you can get the f of t. The f of t is just the Laplace inverse of f of s, which is this part. This part is f of s. S over s squared plus 9. Now this is very easy. This is just the cosine of 3t. So this is f of t. But what you really need is f of t minus a. The value of a is 1/2. So what you really need is f of t minus 1/2. So all you have to do is to replace this t by t minus 1/2. So it's the cosine of 3t minus 1/2. Okay, all you have to do is to plug in this in the formula. So this, the Laplace inverse of this is this formula, this cosine of 3t minus 1 half, and then times u of t minus 1 half. And then you calculated the Laplace inverse. Okay, engineers, so in this video we are going to see a differential equation that actually needs these formulas to make the solution. Alright? See you in the next video.